Here we have an example of a parabola that's given us a focus at 2, 4, and we also have a directrix as the line x equals -4. So I went ahead and plotted those to let us know what we have. Now we have to find the equation, we have to find the endpoints of the latus rectum, and we also have to find the vertex. So let's figure out what we know about these things and see where we can go from there. What do we know about the focus and the directrix? In all of the other problems that we've done and in the definition, the formulas, the vertex was always in the center, in the middle of the focus and the directrix. Because if you'll remember, we had that A business. A, remember, is the distance from the vertex to the focus and also from the vertex back to the directrix line. So let's see, it is 1, 2, 3, 4, 5, 6 units between the directrix and the focus. So 1, 2, 3, let's see about, oops, let me do that in a darker blue here. What about here? If I put the vertex right here, is that exactly in the middle? I would have 1, 2, 3 units to the directrix and 1, 2, 3 units to the focus. So that would be directly in the center, making our A the exact same, which it should be. That would make our A value 3 units back to the directrix and 3 units forward to the focus. That tells us that our vertex is the point -1, 4. We can just plain name that point at this time. Now, if we know that A is 3, then that means we also know 4A, because it'd just be 4 times 3, which would be 12. So that tells us that our latus rectum is going to be 12 units long. So remember, the latus rectum is going to run through the focus and connect as on its endpoints the parabola itself. So we need to decide kind of which way this parabola is going to open before we can plot that out. Remember that the parabola has to open up around the focus. So here's the vertex. If we're going to open around the focus, it has to open to the right, so that it's like arms enveloping the focus. So if we know that this thing opens to the right, then it's going to be opening something like this. Then that means that our latus rectum has to run vertically this time. So it's going to be 12 units long, half on one side, half on the other. So 1, 2, 3, 4, 5, 6 units up, and 1, 2, 3, 4, oops, did I count that right? 1, 2, 3, 4, 5, 6 units down. That means that my bottommost endpoint of the latus rectum is the point 2, -2, and the topmost one is the point 2, 10. So those are the endpoints of the latus rectum. That's what allows us to be able to draw in that parabola nicely. Okay, last thing is our equation. If we know that this opens to the right, it has to follow the formula that says y minus k, quantity squared, equals plus or minus 4a times x minus h. We always start off with that nice standard form, and I'm using the y squared one because this one's opening to the right. Alright, what do we know here? Well, we know that the vertex is at -1, 4. So that means that h is -1 and k is 4. Be very careful about where you put these in. Put them in the right place. We also know that 4a is 12. And because this is opening to the right, that's going to make that a positive. So let's clean this up. That would make our equation y minus 4, quantity squared, equals positive, so we don't have to write that. 12 times x minus a -1 would be plus 1. So there would be our equation of our parabola.